Okay, this is third question on electrostatic potential and capacitance chapter. This is question on capacitor. These type of questions are repeated in many competitive exams. Okay, this is a question on capacitor. See here, if the plates of a parallel plate capacitor are connected to a battery, are moved closer to each other, then they are given different statements. See, for these type of questions you have to check whether the battery remains connected or it is removed. Now here in this question they have mentioned that if the plates of the parallel plate capacitor connected to a battery are moved close to each other, means battery remains connected. They have not mentioned that the battery is removed. If the plates of a parallel plate capacitor connected to a battery are moved closer, means now the separation is made less with battery connected. Now if battery remains connected, this battery will maintain the PD across the capacitor plates, that is V will be constant. Just you have to check which quantity will be maintained constant. If battery remains connected to the capacitor, then V must be constant. Okay, if you make the changes by removing the charging battery, then Q will remain constant because there is no source of charge once you disconnect the battery. If battery is disconnected and afterwards the changes are made, like dielectric constant is introduced or separation between the plates is increased or decreased, then Q will be constant. That is when battery is disconnected. If the battery remains connected, then you should take V constant. This battery will maintain constant PD across the capacitor plates. Then we will check first statement, the charge stored in it increases. Okay, we can write Q as equal to C into V. This is a basic formula. Now if you reduce the distance between the capacitor plates, we have C is equal to epsilon naught A upon D. As this D is reduced, then C must increase. Okay, C increases but V is constant, therefore Q will increase. That statement A is correct. By reducing the distance, capacitance increases, therefore charge will also increase. Second statement, the energy stored in it decreases. Okay, for energy stored in the capacitor, I'll take this formula, U equal to half CV square, because I know that this quantity is constant, then I have only one variable and I know how this C is changing. C is now increased, then U must also increase. Therefore here the energy stored in it decreases, they have mentioned, then it is wrong. Actually energy stored in it increases. And statement 3, its capacitance increases. Okay, that we already observed, capacitance will increase. Statement C is correct. The ratio of charge to its potential remains same. The ratio of charge to its potential remains same, they have mentioned. That is Q by V equal to C actually. But they have here it is increasing. It is increasing means this statement is wrong. The product of charge and voltage increases. The product of charge and voltage increases. Okay, the product of charge and voltage means here voltage is constant. What happens to this Q? Q is increasing. That we observed in statement A only, that because of increase in C, Q is increasing. Q is increasing means the product of Q and V will increase. That statement A is also correct. Therefore statements A, C and E are correct. A, C and E are correct.